class, now we're going to talk about section 10.4, which covers some properties of logarithms. So, first up, I just introduced a new word of the day, logarithm. What are logarithms? Logarithms are the inverses of exponents. So, if I say I have 2 cubed is 8, what a logarithm is saying is what power would I raise 2 to in order to get 8? So let's work through a few examples of these, because this is a new concept and it's going to take us a minute to get there. So this first question I've already done, and it's saying, okay, what power do I raise 2 to in order to get 4? Well, the answer is 2. Here I have what power am I raising 3 to in order to get 27? The answer is 3, because 3 cubed is 27. Here, log base 5 of 125 is asking what power do I raise 5 to in order to get 125? That is also 3. So let me slow down a little bit. Log base 2 of 16 is saying what power do I raise 2 to in order to get 16? Well, 2 to the 4th is 16. I can also ask log base 4 of 16. I could say 4 to the what power gives me 16? And that's going to be 2, because 4 squared equals 16. So if I were you, I would definitely recommend practicing between the logarithm and the exponential notation. That's how I really learned to get these down. So let's talk about some special properties of logarithms. So some special properties of logarithms are this. If I have, let me work through some examples. So for example 1, we're going to use this rule right here. So if I have log base 7 of 7, that's always going to give me 1. Now why does that work? Remember, logarithms are asking what power do I raise something to get this. So 7 to the what power is 7? Well, that's going to be 1. All right. If I have log base 6 of 1, that's asking what power do I raise 6 to get 1? Well, remember, anything to the 0 power is 1, so it's going to be 0. For rule 3, I'm saying log base 3 of 3 to the 4th is just going to be 4, right? Because this is asking what power do I raise 3 to in order to get 3 to the 4th? Well, the answer is 4. This is the only tricky one right here is rule number 4. If I have 5 to the log base 5 of 2, okay, that answer is always going to be 2. It's going to be your r. So if I have b to the log base b of r, it's going to be r. So this is 2. Another thing you need to know about logarithms are some of its properties. So the product property states that I can pull it apart. So if I had log base a of xy, that's the same as log base x plus log base y. When I'm dividing, I'm going to be subtracting. And this makes sense, right? Because when we were working with exponents, when we multiplied them together, we would add their exponents, right? And the answer to logarithms is the exponent power. And when we were dividing exponents, we would have, we would subtract. Like if I had 5 cubed over 5 squared, that'd be 5 to the 3 minus 2, which is 5 to the 1st. So tying it back to the exponent rules. Remember our power property, if I had 5 squared cubed, I multiply them together. So I can just move that power to the front. And again, anything log base of 1 is going to be 0. So let's take a look. I can rewrite this. I have log base 6 of 7 times 9. that gives me log base 6 of 7 plus log base 6 of 9. And I know these don't work out nicely, and that's okay. Here, I can use my quotient rule. I have log 15 log base 9. The base is really important for us to remember. Log base 9 of 15 minus log base 9 of 7. Here I'm going to have 1/2, because I'm pulling this exponent to the front, 1/2 log base 5 of 8. So that's how we use our logarithm properties. E is an irrational number and not a variable. It's the button on your calculator that you've probably stared at. You push it, you get a really ugly looking number, right? And you weren't quite sure what to do with it. So this is how you find the natural log. This is how you find E. That's a concept we're going to cover in chapter 13, so look forward to that. But we use E because E is really important. That's the natural logarithm, another button on your calculator you haven't seen. And natural logarithm is log base E, okay? So just trying to demystify some of the mystifying buttons on your calculators. The common logarithm, when you push the logarithm button on your calculator, it's log base 10, right? We have a base 10 number system, so we typically do things log base 10. So let's keep in mind that logarithms and exponential functions are inverses, okay? So they're both one-to-one functions, right? Because you have to be a one-to-one function in order to have an inverse. Also note that the natural log of E is 1 because log base E of E equals 1. That's like asking E to the what power is 1? Well, it's going to be